It followed from the special theory of relativity that mass and energy are but different manifestations of the same thing. A somewhat unfamiliar conception for the
In this documentary, we will delve into Einstein's views on God and the universe, unveiling a fresh and fascinating perspective on the world around us. Albert Einstein, who began playing the violin at the age of 6, was captivated by composers like Mozart and Bach, whose melodies enriched this video. Though he also enjoyed Schubert and Vivaldi, his admiration for them was somewhat lesser. Mozart evoked in him a beauty and simplicity that he regarded as almost divine, as if it revealed a cosmic truth. In Bach's music, he discovered a precision and complexity akin to mathematics, which, in his view, resonated with the fundamental laws of the universe. According to some accounts, he felt that music stimulated his imagination, allowing him to perceive complex ideas from a fresh perspective. He once remarked, "Life without playing music is inconceivable to me." Childhood and first questions. Albert Einstein was born on March 14, 1879 in Ulm, in the Kingdom of Württemberg, part of the German Empire. Although his family had Jewish roots, religion did not play a central role in his daily life or education. During his early years, Albert was first introduced to both science and religion. It is said that as a child, he was mesmerized by a compass his father showed him, wondering what made the needle always point in the same direction. This sense of wonder about nature's mysteries was an early spark that ignited his passion for science. Though his family was not religious, Einstein went through a brief phase of religiosity during childhood. Around the age of 12, he became interested in Jewish practices and began studying them on his own. However, this period of deep faith did not last long. he soon started reading scientific texts and developing an analytical mindset, leading him to question organized religion. This perspective was further reinforced by books that described a universe governed by unchanging laws, understood through reason and observation. Adolescence and early concerns. During his teenage years, Albert attended the Luitpold Gymnasium in Munich, a traditional school that emphasized rigorous learning and strict obedience to authority. Einstein disliked the authoritarian teaching style of the school and had little patience for rigid rules. He preferred to learn at his own pace. While studying at the gymnasium, he began to question religious teachings, as the stories in the Bible clashed with his understanding of natural laws. He pondered how religious narratives could be taken literally when they seemed to contradict scientific knowledge. Beyond his skepticism toward religion, Einstein also developed a deep interest in classical philosophers and scientists. He was captivated by the ideas of thinkers like Kant and fascinated by how great scientists such as Isaac Newton described the universe in mathematical terms. This reinforced his passion for seeking knowledge through reason and experimentation, rather than relying on faith. To continue his education in a more liberal environment, Einstein moved to Aarau, Switzerland, where he completed high school at the Cantonal School led by Jost Winterler. Here, he found a setting that suited his independent learning style and critical thinking. It was in Aarau that he began to delve deeper into his ideas on physics, challenging conventional notions of space and time, a path that would eventually lead him to his theory of relativity. Studies at the Zurich Polytechnic. During his time as a student at the Zurich Polytechnic, Albert experienced a crucial period of intellectual and personal growth. While training to become a physics and mathematics teacher, his way of thinking and perceiving the world continued to evolve. He was drawn to the philosophy of science, particularly its focus on explaining the cosmos through fundamental principles and theories. Einstein began to reflect on the relationship between science and religion, considering how they sometimes clashed in their attempts to explain reality. During this period, he discovered the works of Baruch Spinoza, a 17th century philosopher with a view of God that differed from traditional Judeo-Christian beliefs. Spinoza argued that God was not a personal entity intervening in the world, but rather that God and nature were one and the same, an idea known as pantheism. According to Spinoza, God was the very order and laws of the universe, not a being governing these laws from above. Einstein strongly resonated with Spinoza's ideas, particularly the belief that the divine resides in the harmony of all things in the universe. The Patent Office. After graduating from the Polytechnic and facing some difficulties finding a job in academia, Einstein secured a position at the Swiss Patent Office in Bern. Starting in 1902, this job turned out to be surprisingly beneficial for his intellectual growth. His role required him to examine inventions and determine whether they deserved a patent, which pushed him to analyze the physical principles behind the machines and devices he evaluated. Although it was a full-time job, it provided him with a stable schedule, leaving him with enough free time to reflect on his own scientific ideas about physics and metaphysics. Einstein and his colleagues at the Patent Office, particularly his collaborator Michele Besso, established what they called the Thinker's Hour. During their breaks, they would engage in discussions on philosophical and scientific concepts, conduct thought experiments, and pose deep questions. In 1905, while still working at the Patent Office, Albert published his special theory of relativity, which revolutionized the understanding of space, time, and motion. This theory demonstrated that measurements of time and space are influenced by the observer's speed, challenging Newton's long-held view of time and space as absolute and unchanging. Thought experiments. Einstein employed a unique technique to visualize complex physics concepts entirely in his imagination. Rather than conducting physical experiments in a laboratory, he would create hypothetical scenarios in his mind to grasp the fundamental principles of nature. At the age of 16, he devised one of his earliest thought experiments. What would happen if he could ride a beam of light and travel at its exact speed? Through this exercise, Einstein realized that time could change, depending on how fast someone moves. And the same applied to space. This insight later led to the development of his special theory of relativity. To formulate his general theory of relativity, he used another thought experiment in which he imagined a person inside a windowless elevator. Einstein proposed that what we call gravity is not a force, but rather the curvature of space and time. According to his general theory of relativity, massive objects, like the sun, bend the surrounding space, causing smaller objects to move toward them. The move to Berlin and World War I. In 1914, the same year war broke out in Europe, Einstein relocated to Berlin. These years profoundly shaped both his professional and personal life. The war deeply influenced his worldview, along with his philosophical and political thinking. The brutality of World War I led him to reflect on the role of scientists and the ethical responsibilities of science. He watched as his colleague aligned themselves with national war efforts, contributing to military technology and weaponry. Appalled, he embraced a lifelong pacifist stance. Although he did not believe in a personal God, the war prompted him to explore the relationship between humanity, morality, and the cosmic order. In his reflections, he used the concept of God to symbolize a system of natural laws, an order that stood in stark contrast to the chaos and irrationality of human warfare. Like many intellectuals of his time, he faced the dilemma of how scientists should respond to war. He became one of the few in the scientific community to openly criticize the nationalism and militarism that had fueled the conflict. During his years in Berlin, which spanned World War I and lasted until 1932, Einstein continued his scientific work, most notably completing the final formulation of the general theory of relativity in 1915. The rise to fame. Einstein's popularity soared to extraordinary levels in November 1919, after observations of a solar eclipse confirmed his prediction about the bending of light around the sun, a key element of his general theory of relativity. This theory expanded upon the concepts of special relativity, redefining gravity as the curvature of space-time, caused by an object's mass. The world reacted with awe. Newspapers across the globe hailed his genius, and overnight he became an international celebrity. General relativity became a symbol of humanity's ability to unravel the universe's mysteries. In the public imagination, Einstein was now seen as a sage, the ideal representation of a scientist. As his fame grew, he began engaging with numerous intellectuals to discuss the nature of God and religion. At times, he expressed deep admiration for the structure of the universe, but dismissed the notion of a God who intervened in everyday human affairs. For him, God was a metaphor for the order and rationality embedded in the laws of physics. The Nobel Prize in Physics. Einstein was awarded the Nobel Prize in Physics in 1921. though not for his theory of relativity, which remained controversial at the time. The Swedish Academy of Sciences honored him for his work on the photoelectric effect, a discovery that had a profound impact on the development of quantum physics. The photoelectric effect occurs when light strikes a metal surface, causing the emission of electrons. Einstein explained this phenomenon by proposing that light is made up of particles, or quanta of light, which we now call photons. Although his theory of relativity had already bought him recognition, the Nobel Prize cemented his status as one of the most influential scientists of his time. Winning the award also had significant financial implications for him. He received 121,000 Swedish kroner, an amount equivalent to 50 times the average annual salary of the era, or 12 years' worth of income. At the time, he was going through a divorce from his first wife, Mileva Maric, and, as part of their settlement, he had agreed to give her the prize money. God does not play dice. Einstein famously stated, "God does not play dice," in a letter to quantum physicist Max Born in 1926. With these words, he expressed his disagreement with quantum mechanics, a branch of physics that he had helped establish. Simply put, quantum mechanics suggests that, at the microscopic level, within atoms and subatomic particles, events do not follow predictable laws, like those in the visible world. Instead, they operate based on probabilities and possibilities. This means that when trying to predict exactly what a tiny particle will do, certainty is impossible. One can only estimate the probability of different outcomes. Schrodinger's cat is a well-known thought experiment that illustrates this concept. Schrodinger, imagine placing a cat inside a closed box, along with a device containing a radioactive atom, a Geiger counter, and a vial of poison. If the atom decays, the counter detects it, triggering the release of the poison and killing the cat. If the atom does not decay, the poison remains sealed and the cat stays alive. The strange part of quantum mechanics is that before the box is opened and observed, the atom exists in a kind of superposition. It has the probability of having decayed and a probability of remaining intact. According to this logic, the cat would exist in a superposition of states, both alive and dead at the same time. Only when the box is opened and observed does the cat choose one of those states. Either it is alive or it is dead. Does our observation determine the cat's state? Does this imply that reality itself depends on our awareness of it? If the cat is both alive and dead simultaneously, what does that mean for our understanding of time and reality? Could multiple outcomes unfold in parallel universes? What happens to the choices we could have made, but didn't? Do they take shape in another reality? Or do they simply vanish? For Einstein, this fundamental randomness was unacceptable. He believed that uncertainty about the future was not an inherent property of the universe, but rather a reflection of our limited understanding of its true nature. He was convinced that there must be hidden laws that, if discovered, would allow us to fully predict the universe's behavior. With his famous phrase, "God does not play dice," he meant that he could not accept a universe governed by chance and probabilities, as quantum mechanics suggested. He believed that everything could ultimately be explained by a set of precise rules, whether or not we had discovered them yet. International travels and cultural encounters. After receiving the Nobel Prize, Einstein became a global traveler, using his rising fame to lecture on his scientific theories and advocate for his pacifist ideals. As he journeyed across different countries, he had the chance to experience various cultures and beliefs, broadening his perspective on deepening his understanding of the world. In 1921, before his Nobel Prize was officially awarded, Albert embarked on his first trip to the United States. Encouraged by Chaim Weizmann, the future president of Israel, he aimed to raise funds for the Hebrew University of Jerusalem. During his stay, he delivered multiple lectures and met prominent figures of the time, including President Warren G. Harding. In 1922, while traveling through Japan for a series of talks, Einstein was so captivated by the country that he recorded in his diary the beauty of its landscapes and the richness of its culture. His journey through Asia introduced him to Buddhism and Shintoism, allowing him to observe how these spiritual and cultural traditions were woven into everyday life. He was known for respecting the many ways people sought to understand the universe. In the following years, Einstein continued his travels. In 1923, he arrived in Palestine, where he was welcomed as a hero and delivered a speech at the Hebrew University of Jerusalem. He also traveled to several European countries, including Spain and France, where he took part in scientific discussions and promoted international dialogue. Attacks on Einstein. Throughout the 1920s and 1930s, Einstein faced both scientific challenges to his theories and anti-Semitic criticism. Among his critics were physicists Johann Stark and Philip Leonard, both Nobel Prize winners and supporters of German National Socialism. Despite their own scientific achievements, they developed a hostile stance toward relativity and Einstein himself, partly due to his Jewish heritage. Leonard and Stark were involved in a movement that sought to discredit relativity by labeling it as Jewish physics, while promoting what they called Deutsche Physik, or German physics. Their opposition was heavily influenced by the political climate of the time, as anti-Semitism was on the rise in Germany, though their views did not gain significant traction internationally. Aware of the growing danger in his homeland, Einstein left Germany in 1933. He relocated to the United States, where he accepted a position at the Institute for Advanced Study in Princeton, continuing his scientific research. Exile. In March 1933, while traveling in the United States, Einstein made the decision not to return to Germany. He was stripped of his membership in the Prussian Academy of Sciences, and his writings were added to the list of banned books. This exile marked a profound shift in his life, both personally and professionally. Leaving his homeland meant losing his country, but it also granted him the freedom to express his political views and continue his scientific work without restrictions. He used his status to warn the world about the dangers of totalitarian rule. Speaking out against oppression, he became a strong advocate for human rights and democracy. Additionally, he promoted support for refugees fleeing Germany and emerged as a leading voice within the immigrant community. The Einstein-Szilard Letter to Roosevelt. In Princeton, Einstein remained dedicated to his scientific work, focusing particularly on the unified field theory, with which he aimed to unify the fundamental forces of nature. His life in the United States brought a stronger engagement with political and social issues. Though he had always been a public advocate for peace, his escape from Europe deepened his convictions. In 1939, Einstein signed a letter addressed to President Franklin Delano Roosevelt, a historic document of great significance in both science and global politics. It warned the US president about recent advancements in nuclear research in Germany. The letter stated, "A single bomb of this type, transported by ship and detonated in a port, could destroy the entire harbor, along with part of the surrounding territory." This warning was based on the discovery of uranium fission, which could release enormous amounts of energy, potentially leading to the development of atomic weapons. Szilard, Einstein, and other scientists were particularly concerned that the United States might fall behind in nuclear research. The document stressed the urgency for the U.S. to accelerate its efforts and proposed securing uranium reserves. It also emphasized the importance of conducting further experiments to determine whether a chain reaction could be harnessed for bomb production. The impact of this letter was profound. It prompted Roosevelt to take action, ultimately leading to the launch of the Manhattan Project, the secret program that developed the U.S. atomic bomb. Regret. Einstein, known for his strong pacifist beliefs, experienced deep regret for his indirect role in the creation of nuclear weapons. When the bombs were dropped on Hiroshima and Nagasaki in August 1945, the immense destruction and loss of human life profoundly affected him. He was horrified by the overwhelming power of the atomic bomb. Over time, his remorse led him to become an even more vocal advocate against nuclear weapons and a proponent of scientific responsibility. Einstein emerged as a strong supporter of arms control and international cooperation to prevent nuclear war. In 1947, he stated, "Had I known that the Germans would not succeed in developing an atomic bomb, I would have done nothing about it." He is often quoted as saying, "I do not know with what weapons World War III will be fought, but World War IV will be fought with sticks and stones." It remains uncertain whether he spoke these exact words or expressed them in various conversations, but he firmly believed that nuclear war had the potential to destroy humanity. Einstein also co-authored the Russell-Einstein Manifesto in 1955, urging world leaders to renounce nuclear war and seek peaceful solutions to international conflicts. Post-war years, Israel and Zionism. After the war, Einstein continued to express his support for Zionism, a movement he had backed since the 1920s. His support was not driven by nationalism or religious fervor, but by the idea of a cultural homeland for the Jewish people. Einstein was deeply aware of his Jewish identity, though his connection to Judaism was primarily cultural and philosophical. He was not religious. His views of God was influenced by Spinoza and shaped his perspective on the Jewish people. He valued their ethical traditions and commitment to justice. Regarding the State of Israel, Einstein supported its establishment in 1948. However, he was an advocate for a binational state that promoted peaceful coexistence and equal rights for both Jews and Arabs. He opposed militarism and warned against extreme nationalism, fearing it would lead to an endless cycle of violence. Einstein had a complex relationship with religion and nationalism. He did not support the idea of a state founded on a specific religion, and was concerned about how nationalism could fuel conflict. His vision for a Jewish state emphasized shared values and culture, fostering an ethical and progressive community. In 1952, after the death of Chaim Weizmann, Einstein was offered the presidency of Israel, but declined, citing his lack of experience for such a role. His decision reflected his self-image as a thinker and scientist, rather than a political or religious leader. The search for a unified theory. Unification in physics was one of Einstein's ultimate goals in his scientific career. He spent the last 2 decades of his life attempting to develop a unified theory that would integrate all fundamental forces of nature: gravitational, electromagnetic, strong and weak, into a single theoretical framework. For Einstein, such a theory would embody the pinnacle of beauty in physics, revealing the underlying unity of the universe. While the scientific community at the time was shifting its focus toward quantum mechanics, he remained dedicated to his pursuit. Despite his relentless efforts, he was unable to develop an accepted unified theory, leaving his work unfinished at the time of his death. Einstein approached mortality and immortality from a philosophical rather than religious perspective. To him, immortality lay in the impact of one's contributions to knowledge and the betterment of humanity, rather than in an existence after death. His legacy in physics, along with his influence on science and culture, exemplifies this form of immortality, where his ideas and discoveries outlived him. The death of Einstein. Albert Einstein passed away on April 18, 1955, at Princeton Hospital in New Jersey at the age of 76. In his final days, he was admitted due to the rupture of an abdominal aneurysm, a condition that had been diagnosed in 1948. On the day of his death, Albert was aware that there was not much the doctors could do to save him, so he refused any surgical intervention. To him, artificially prolonging life had no meaning. He preferred a natural death. In his own words, "I want to go when I wish. It is tasteless to prolong life artificially. I have done my share. It is time to go. I will do it elegantly." During his last hours, Einstein remained lucid and mostly silent. It is said that, while in his hospital bed, he was still taking notes. perhaps on his unfinished unified field theory. He passed away in the early hours of April 18th. His exact last words remain unknown, as he spoke them in German, and the nurse attending him at the time did not understand the language. This had left his final words shrouded in mystery, though some speculate that they may have been personal reflections or philosophical thoughts. After his death, a controversial event took place. During the autopsy, pathologist Thomas Stoltz Harvey removed Einstein's brain without the family's authorization, intending to study it. This act sparked decades of ethical and legal debate. Harvey kept the brain, even taking it with him when he moved. For years, he did not publish any studies, though he occasionally allowed other scientists to examine it. Eventually, portions of Einstein's brain were distributed to various pathologists and neurologists around the world. Some studies suggested possible structural differences might have been linked to his mathematical and spatial abilities. Even so, many scientists argue that the conclusions drawn from these studies lack sufficient scientific rigor. God, according to Einstein. Since adolescence, Albert had read philosophical works by thinkers such as Kant, Hegel, Hume, and Schopenhauer. In Ethics, a treatise by Spinoza, he encountered the idea of God as the totality of natural laws governing reality. In 1929, in a letter exchange with Rabbi Herbert S. Goldstein, Einstein wrote, "I believe in Spinoza's God, who reveals himself in the orderly harmony of what exists, not in a God who concerns himself with the fates and actions of human beings." During a conversation with German writer Alfred Kerr, he stated, "I cannot conceive of a personal God who directly influences the actions of individuals. My religiosity consists of a humble admiration for the infinitely superior spirit that reveals itself in the little that we can understand of the world." Thus, Einstein did not believe in a God who intervened in human affairs, but rather in one that manifested through the ordered system of the natural world. He also voiced his discontent with organized religion, which he viewed as superstitious and authoritarian, believing such institutions opposed the freedom of thought. Nevertheless, he expressed deep respect for the teachings of Jesus Christ. In a 1930 interview with George Sylvester Viereck, when asked about Christianity's influence on his life, he responded, "As a child, I received instruction in both the Bible and the Talmud. I am Jewish, but I am captivated by the luminous figure of the Nazarene." When asked whether he accepted the historical existence of Jesus, he responded, "Unquestionably. No one can read the Gospels without feeling the real presence of Jesus. His personality pulsates in every word. No man can deny the fact that Jesus existed, nor that his sayings are beautiful. Even if some of them had been stated before, no one has ever expressed them as divinely as he did." Though he admired the figure of Jesus, he held a different view of the Bible's writings. In 1954, After reading philosopher Eric Goodkin's book, Choose Life: The Biblical Call to Revolt, Einstein sent the following response to Goodkin. The Word of God is for me nothing more than the expression and product of human weaknesses, and the Bible a collection of honorable but still primitive legends that are nonetheless quite childish. However, Albert did not identify as an atheist. In the same interview with Viereck, he remarked, "I am not an atheist. The problem at hand is too vast for our limited minds. We see a wonderfully organized universe, governed by certain laws, but we only vaguely understand those laws." In his 1954 book, Ideas and Opinions, he wrote, "I cannot conceive of a God who rewards and punishes his creatures, or who has a will of the kind we experience in ourselves. A man's actions are determined by necessity, external and internal. So in the eyes of God, he cannot be held responsible any more than an inanimate object can be responsible for the movements it undergoes." Ultimately, Einstein had a nuanced view of God that did not align with traditional religious beliefs nor with strict atheism. Something fitting for a genius with original, independent ideas. To him, God was a metaphor for the deep structure of the cosmos, a kind of superior and incomprehensible intelligence underlying the laws of nature. Life after death, morality, and the soul. Einstein did not believe in an afterlife, at least not in the way many religions describe it. He saw no reason to think that individuals continued to exist externally after death. He also rejected the idea of a God who punishes and rewards, believing such notions stemmed from fear or human ego. To him, ethics and morality were purely human concerns that did not require a higher or supernatural authority. In other words, our actions matter because we choose them, not because some divine entity is keeping score. Rather than viewing the universe as chaotic or subject to divine whims, Einstein maintained that every event has a specific cause within the framework of natural laws. One such law is gravity, the curvature of spacetime that causes planets to orbit stars and objects to fall. Another is the speed of light in a vacuum, which remains constant for all observers. There is also the conservation of energy, the principle that energy cannot be created or destroyed, only transformed from one form to another. From Einstein's perspective, human actions are shaped by external factors, such as biology, environment, education, and experiences, all beyond individual control. For this reason, he argued that punishing or rewarding someone for their actions made little sense from a divine standpoint. Under this non-religious view of the universe, Einstein saw human existence as limited to a lifetime, with no continuation of consciousness or soul after death. In fact, in one of his letters, he wrote that he could not conceive of a soul surviving the death of the body. To him, the essence of human existence lay in living a meaningful life, connected to others. Cosmic spirituality, Einstein's religion. Albert had a unique way of thinking about religion and spirituality, something he referred to as cosmic spirituality. Like other great minds such as Leonardo da Vinci, Einstein possessed an insatiable curiosity and a deep passion for exploring the world around him. He did not believe in a God that resembled humans or made decisions about people's lives. Instead, he saw the universe as full of mystery and order, which inspired in him a profound feeling, something akin to a religious sense. The stars and planets seemed to move in a kind of perfectly choreographed dance, governed by laws he longed to understand. What fascinated him most was how everything in the cosmos followed such precise rules. He saw in these laws a form of harmony, a silent order that connected all things. For instance, he was captivated by the way light always traveled at the same speed, regardless of who measured it or from where. That same sense of wonder extended to small, everyday things: the flight of a bird, the shape of a leaf, or the way water flows. In a 1930 essay, Einstein described 3 ways in which people come to believe in God. First, there is fear, which leads humans to invent supernatural beings. Then comes the social need for love and support, which drives people to seek a higher power. But Einstein believed that the most mature form of religiosity came from the feeling of cosmic spirituality. To him, science stood in opposition to the first 2 ways of believing in God, but was a companion to the third. Although he was not religious and did not believe in a God who influenced humanity, selective readings of his writings have led some to portray him as a religious and exemplary figure. He believed that life had meaning when lived for others, and when people acknowledged their dependence on the work of those who came before them. He wrote, "I think 1,000 times a day that my external and internal life is built upon the labor of other men, living and dead. I feel I must exert myself to give as much as I have received, and continue to receive." Einstein held ideals of kindness, beauty, and truth, values that guided his life, while luxury and material success seemed meaningless to him. He wrote, "No wealth can advance humanity, not even if managed by someone with the best intentions. Money only leads to selfishness and inevitably results in abuse." He considered the military a stain on civilization and harbored deep disdain for violence and blind patriotism. He once wrote, "How cynical, how contemptible wars seem to me. I would rather be torn to pieces than take part in such a vile act." philosophy on Einstein. By Einstein's time, translations of Eastern texts, such as Lao Tzu's Tao Te Ching and the Buddhist Dhammapada, were already available in German and English. These works began circulating in academic circles across Europe, and with his deep interest in new philosophical ideas, Einstein had the opportunity to read some of them. He believed that Eastern philosophies resonated with his skepticism toward traditional Western religions. In his book, My View of the World, he remarked, "The component of cosmic religiosity is much more pronounced in Buddhism, as demonstrated by the magnificent writings of Schopenhauer. The great religious minds of all ages were admirable for this religiosity, which was free from dogmas and any human-like God." Schopenhauer shared with Buddhism the idea that life is, for the most part, suffering. To him, existence was marked by pain, dissatisfaction, and endless desire. A perspective at the core of Buddhist teaching. He admired how Buddhism acknowledged this reality and provided a path to escape suffering by overcoming desire. Furthermore, Schopenhauer rejected the notion of an omnipotent God, instead proposing an impersonal force, the will, as the driving force of existence. In letters and interviews, Einstein referred to Schopenhauer as a spiritual guide. He deeply admired his independent thinking and ability to develop original ideas. If we examine certain Buddhist teachings, we can see surprising parallels with Einstein's perspective on the universe and life. Buddhism does not recognize an omnipotent creator God, as found in Judaism, Christianity, or Islam. Instead, it is a way of life centered on personal practice, mental development, and emotional growth. According to Buddhist thought, the universe operates according to unchanging principles and laws, without the need for a divine entity consciously guiding it. The cosmic religiosity Einstein spoke of aligns with this approach, a deep reverence for life and a profound humility before the vast mystery of the cosmos. In Buddhist philosophy, the reality we perceive is an illusion shaped by our perceptions, ignorance, and attachments. Einstein did not describe reality as an illusion in a spiritual sense, yet his theory of relativity demonstrated that space and time are dependent on the observer. In this context, the Dalai Lama, the spiritual leader of Tibetan Buddhism, has spent decades fostering respectful dialogue between scientists and Buddhists. In fact, he has stated that if scientific discoveries were to contradict a Buddhist teaching, Buddhism should adapt to this new knowledge. Like Einstein, who championed free thought unbound by dogma, the Dalai Lama encourages his followers to question, base their beliefs on experience, and rely on reason. Promoting a culture of peace and addressing conflicts without violence is a principle the Dalai Lama upholds, one that Einstein also strongly supported. Can we know God? The limits of human knowledge. When Einstein spoke of the mind of God, he did so metaphorically, referring to the quest to uncover the fundamental laws of the universe. He believed that, due to our limitations, humans can grasp only a small fragment of reality, and by extension, only a glimpse of the mind of God. His theory of relativity helped illustrate that our perception and understanding of the world are shaped by the constraints of our position in space and time. Simply put, special relativity teaches that concepts we consider absolute, such as time and space, are actually relative and change depending on an observer's speed and position. For instance, time does not flow equally for everyone. Aboard a spacecraft traveling at high speed, time slows down compared to those remaining on Earth. Similarly, general relativity shows that space and time are not just passive backdrops where events unfold. They can bend and curve. This makes the universe far more intricate than our human intuition can fully grasp. We experience the world on a very limited scale compared to the vastness of the cosmos. Einstein saw these limitations as markers of the boundaries of human understanding. There would always be mysteries beyond our complete comprehension. It is as if we are peering at the universe through a window that lets in only part of the light. Our knowledge is an incomplete map, and the more we learn, the more we realize how much remains unknown. For Einstein, this mystery was what made science so extraordinary. A continuous pursuit, never truly finished. In his view, approaching God or ultimate reality was like catching a fleeting glimpse of an infinite and unknowable truth. The cosmic mind. Imagine for a moment that every galaxy, every planet, and every atom is a piece of something vast and intricate. The cosmos could be seen as a kind of body of God, where everything is interconnected, and each being plays an essential role within a greater organism. Austrian physicist and philosopher Erwin Schrödinger suggested that the intelligence and order of the universe might reflect a cosmic mind. He believed that the separation between observer and observed was an illusion, that all reality could be united in a single cosmic consciousness, with each sentient being as a fragment of it. This would imply that an inherent intelligence or fundamental order exists in the universe, one in which all things are included. In this view, the cosmos itself could be considered God, not as a being with a specific form or personality, but as intelligence that expresses itself through physical laws. In other words, God would not be something outside the universe, but the universe itself, in its entirety. Thus, when we observe the cosmos, we are not looking at something separate from us, but at something we are intrinsically part of. Just as our cells depend on us for their existence, and we in turn depend on them, perhaps we, collectively, function as cells contributing to the existence of a much greater cosmic being. But what if God had another God? In that case, the cycle would have no clear end, but would extend infinitely beyond our perception. Perhaps we are part of an endless chain of universes and consciousnesses, where each level contributes to the next, and every being is, in turn, a fragment of something even more immense. Is the universe designed to allow life? The laws and constants of the universe appear to be finely tuned for life. Even the slightest variation would make the formation of atoms, stars, and planets, and therefore life as we know it, impossible. The precision of this fine-tuning is seen by some as evidence of intentional design, leading to discussions about the existence of God. Gravity, described by the gravitational constant, is responsible for shaping stars, galaxies, and planets. A minuscule change in gravity, comparable to removing a single grain of sand from an immense beach, could have caused the universe to either expand too rapidly or collapse immediately. Likewise, the electromagnetic force governs interactions between charged particles and is essential for forming atoms and molecules. If this force had been altered by an unimaginable tiny amount, the universe would not have produced key elements for life, such as carbon and oxygen. A faster speed of light would result in a much smaller universe. While stars would still form, they would disintegrate too quickly, making the evolution of life nearly impossible. On the other hand, if light traveled more slowly, the universe would expand so rapidly that galaxies might never come into existence. Without the moon, life as we know it might never have emerged, or it could have evolved in an entirely different way. Without the moon's gravitational pull, Earth's axial tilt would become unstable, leading to drastic variations and a chaotic climate. These abrupt shifts would disrupt ecosystems, making it difficult for complex life forms to develop and thrive. Earth is located within what is known as the habitable zone of the solar system, a region where temperatures allow liquid water to exist on the surface. If our planet were just 5% closer to the Sun, it would be too hot to retain water. If it were 5% farther away, the surface would cool enough for water to freeze across the entire planet.
I don't ever slow up, no I don't take shit. I got no love for the fakeness if you wanna play tough.
Similarly, a strong magnetic field, an atmosphere with the right density and composition, the presence of abundant water, and active plate tectonics have all contributed to the development of life. Jupiter and Saturn also play a crucial role in Earth's habitability, acting as gravitational shields that reduce the number of comets and asteroids reaching the inner solar system.
I got a vendetta against people who patented being negative when you should be getting after it.
It is tempting to assume that such precise conditions are not mere coincidences, but rather signs of intelligent design. It all seems too perfect to be random. However, there are alternative explanations to consider. According to the anthropic principle, we perceive the universe as fine-tuned for life because, naturally, we exist in a universe that allows life. As Stephen Hawking put it, we see the universe as it is, because if it were different, we would not be here to observe it. Another possible explanation is the multiverse hypothesis, the idea that our universe is just one of many, perhaps an infinite number, each with its own set of physical laws and constants. Most of these universes would probably not have conditions for life, although some would. We would live in one of those lucky universes. Thoughts in my head, a collage and they spread. I'll be great one day, going off of my meds. No, I'm not giving up, no, I'm not giving in. I will make it to the top, taking off in the wind, I gotta make it. The simulation hypothesis is an intriguing idea, suggesting that the universe was created by a higher intelligence, possibly an advanced civilization with immense technological capabilities. In this simulation, the constants and laws of physics would function like programmed codes, carefully calibrated to allow the universe to evolve in a specific way, with the potential for life to emerge. Our reality could be comparable to an extraordinarily complex video game, where conscious beings interact within an environment designed by a superior intelligence. Ultimately, the fine-tuning of the universe could also be interpreted as evidence of the God described in human religions. From this perspective, God is the architect of the cosmos, the force that sets its fundamental laws in motion, adjusting each constant to make life and consciousness possible. And if this fine-tuning truly reflects the work of a supreme mind, is our universe a perfectly balanced creation? Or just one of countless versions in the search for perfection? If Einstein's mind of God sought harmony, are we living in its first successful outcome? Or merely another attempt toward achieving that balance? Could previous versions of ourselves have existed in those earlier universes, each striving to make sense of a reality just slightly different from our own? God according to Galileo, Newton, and Hawking. We have explored Einstein's concept of the mind of God, cosmic harmony, and Spinoza's God. But what ideas did other scientific geniuses hold? Galileo, a staunch defender of heliocentrism and one of the fathers of modern science, believed that the universe operated under laws set by God. To him, these laws were fixed, and the scientist's role was to uncover them. He saw science as a way to approach the mind of God by deciphering the mathematical order of nature. Galileo described the universe as a book written in the language of mathematics, placed by God within human reach to be understood. At the same time, he expressed reverence for the mystery of divine creation, acknowledging that certain aspects of divinity and the cosmos lay beyond human comprehension. Isaac Newton, in turn, viewed God as the architect of the universe, the creator who established the fundamental laws of nature. In his Principia Mathematica, he depicted a structured cosmos where every movement and change followed the laws of physics, upheld by God's will. Although Newton admired thinkers like Spinoza, he did not share his vision of God. He believed in a personal deity separate from the universe, who existed beyond creation, yet remained actively engaged with it. Newton believed that God actively intervened in the world, particularly in natural phenomena that seemed difficult to explain. While he acknowledged the existence of fixed laws, he maintained that divine will could override them whenever necessary. For Stephen Hawking, the idea of God could be understood as a metaphor for the fundamental laws governing the universe. Like Einstein, he was skeptical about the existence of a personal deity. He did not believe in a being that created and maintained the universe, or one concerned with human destiny. Although he occasionally used the word God in his writings, such as in A Brief History of Time, he did not mean a conscious or personal entity, but rather the inherent order of physical laws. In The Grand Design, Hawking concluded that God was not necessary to explain the universe's creation. He argued that the Big Bang could have occurred spontaneously due to the laws of physics, particularly quantum gravity. He believed that if humanity could uncover a theory of everything, one that fully explains all forces and physical phenomena, we would understand the entirety of existence without needing to invoke God in the equation. The differences in opinion among these scientific giants were likely influenced by their historical and cultural contexts. Galileo and Newton lived in an era where religion played a dominant role in all aspects of society. Science was still in its infancy, and natural phenomena were often interpreted as the direct work of an intentional God. For Einstein and Hawking, institutional religion had far less influence. As science progressed, naturalistic interpretations of the universe became increasingly prevalent. Scientific theories like relativity and quantum mechanics have provided explanations for phenomena once attributed to divine intervention. If modern physics has replaced myth, could it one day uncover a truth so profound that it becomes indistinguishable from the divine? What if the theories that explain the universe are not a rejection of the divine, but rather its true expression? What mysteries still lie hidden in the cosmos, waiting for the scientists of the future? Will they one day discover the theory of everything, the ultimate explanation that unifies all forces of the universe? And if they do, will that theory serve as proof that the universe is not just a system of laws, but perhaps the infinite mind of God itself.